And now, a little bit of history.
The excavated remains of a Roman town at Tharos, Sardinia. The layout of the town can be clearly seen, and the buildings, both private and public, can be identified. From places like this, we can start to get a picture of the lives of the people that walked these streets 2,000 years ago. And in Italy, the center of the Roman Empire, it's possible to pick out other remains of Roman life.
The granite quarries of Santa Teresa were used between the 2nd and 4th century AD, and they were probably the property of the imperial household.
Once you get your eye in, there is evidence of the workings all about. There are half-finished columns intended for buildings all over the place. Running out into the sea are the remains of a Roman quay where the boats loaded up the prepared columns and blocks. In the living rock are chisel marks where blocks were being worked on.
At that time, the blocks, and above all the columns, were exported using large cargo ships. Without doubt, columns from Santa Teresa were exported to Rome, where they can still be seen in archaeological sites. There are probably others in other archaeological areas, but we need to investigate these further.
How do they know where the columns and blocks from here have ended up? The clue is in the rock itself. It's granite. There are 3 elements in the granite, uranium, potassium, and thorium, which are naturally radioactive. They emit gamma rays. And every granite is different. They are all of different ages and have different amounts of these 3 elements in them. They give a chemical fingerprint that can be matched up with any granite artifact you come across. And they turn up in some unlikely places. Windsor Park, England. The ruins from the Roman town of Leptis Magna in North Africa found their way to England in the 19th century. Olwen Williams Thorpe wants to know where these granite columns originally came from. She's looking for their chemical fingerprint with a gamma ray spectrometer.
This white object is what we call the probe, part of the gamma ray spectrometer. Now that's a machine designed to measure gamma rays. Inside that probe, in the end of it, there is a crystal. The crystal is made of mostly of sodium, and how it works is that gamma rays are zapping into it. When they enter the crystal, they produce tiny flashes of light. And essentially, all that we're doing is counting the number of flashes of light, and we're measuring the intensity of each flash of light, and that tells us how many gamma rays we're looking at or detecting and what elements the gamma rays are coming from.
Stored in the machine is the uranium, potassium, thorium signature for these columns. All she has to do now is match it up with what she already knows of quarry sites in the Mediterranean.
It's a typical signature of a granite which comes from a quarry in the northwest of Turkey, in an area called the Troad. So those 3 elements tell me that that column is very likely to come from that particular quarry, where we know the Romans were quarrying, producing columns. We've got columns left at some of their quarrying sites, and the chemistry matches up. The column and the quarry, they match very precisely, and so we can be fairly sure that that column comes from northwest Turkey.
What does this tell us? How does chemistry help our understanding of the Romans?
What it tells us is something about the level of sophistication in trade and movement of goods in the ancient world. What we've got here is, in the Roman Mediterranean area, we've got huge granite quarries being exploited between the 1st and 4th centuries AD, massive amounts of granite being taken away to make columns. They are being shipped across the Mediterranean, literally thousands of kilometres. The level of sophistication that the Romans reached was really not equalled in Europe until the industrial period.